What's going on, everybody? Welcome back to my YouTube channel. Look at this nice and beautiful question on the board that we're going to be solving. And the question says, find the values of x for which x to the 5 minus 1 is equal to 0. Well, there is a property we can apply, which is when we have x to the n minus 1, this is equal to x minus 1 times x to the n minus 1 plus x to the n minus 2 plus x to the n minus 3 until we get to 1. So this is a property that we're going to be using to solve this question. And if you notice, they look very much alike. So now that is, this expression can be x minus 1. So x minus 1 times, remember our n is 5. So this is x to the 5 minus 1, that's 4. So this is x to the 4 plus 5 minus 2, that's 3. So this is x to the 3 plus, this is 5 minus 3, that's 2. So this is x to the 2, which is x squared. You notice that the powers reduce by 1. So plus, this becomes x to the 1 and then plus x to the 0. So on simplifying further, we're going to have x minus 1 times x to the 4th plus x to the 3 plus x squared plus, now x to the 1 is same as x plus x to the 0 is 1. And this is equal to 0. So I'm supposed to equate this to 0. Good. Now we have two cases. We have x minus 1 to be equal to 0, or we have x to the 4th plus x cubed plus x squared plus x plus 1 is equal to 0. Now we're going to be solving these cases one after the other. So for case 1, we have x minus 1 to be equal to 0. And to get the value for x, I'm going to be moving negative 1 to the right hand side. So as negative 1 crosses to the right, it becomes positive 1. So this is one value for x. Now for us to get the other values of x, we're going to be solving the second case. Let's do that on the next slide. Now for our second case, let's call this case 2. We have x to the 4th plus x to the 3 plus x squared plus x plus 1 to be equal to 0. Now we're going to be dividing through by x squared. So I'll divide through by x squared. So let's do that. So we have x to the 4th divided by x squared plus x cubed divided by x squared plus x squared divided by x squared plus x divided by x squared. You notice I'm dividing through by x squared, and this is equal to 0 divided by x squared. Now notice x to the 4th divided by x squared, I'm going to be having x squared plus x cubed divided by x squared, I'm going to be having x plus x squared divided by x squared, I'm going to be having 1 plus, now x divided by x squared, I'm going to be having 1 all over x plus Now here I have 1 all over x squared to be equal to 0 divided by x squared is 0. Now my next step will be for me to bring out the terms with x squared together and also bring out the terms with x together and then the constant term. So firstly, the terms with x squared. So we have x squared here plus 1 over x squared. So plus 1 all over x squared. And then plus x, the terms with x, plus 1 all over x, plus 1 all over x. And then lastly, we have 1. And this is equal to 0. So our next step will be for us to apply substitution. I'm going to say let this expression, which is x plus 1 over x, x plus 1 over x, be equal to y. So that means wherever I see x plus 1 over x, I'm going to be substituting y there. So I'll call this equation star. Now, I also need a term with x squared. And how do I get the term with x squared? Well, I'm going to be squaring the both sides of equation star. So this is x plus 1 over x. I'll square the left-hand side equal to, I'll also square the right-hand side. Now let's expand. This becomes x squared. So x squared plus 2 times x times 1 over x. That's 2 times x times 1 over x. And then plus, now 1 over x all squared is 1 over x squared. And this is equal to y squared. Now notice that x can cancel off x so that we have x squared plus 2 times 1, that's 2, plus 1 all over x squared to be equal to y squared. Now I'm going to be arranging this so that it looks like this. So rearranging, we're going to have x squared plus 1 over x squared, so plus 1 all over x squared, and then plus 2 to be equal to y squared. Let's continue on the next slide. Now we have to isolate x squared plus 1 over x squared by moving 2 to the right hand side. So we have x squared plus 1 all over x squared to be equal to y squared. As 2 crosses to the right hand side, it becomes minus 2. So that means x squared plus 1 all over x squared is equal to y squared minus 2. And we're calling this equation star star. So that means wherever we see this expression, we'll be substituting this. Now let's substitute this into our previous equation. Let me show you real quick. Alright, so this is the equation we are substituting into. So for x squared plus y squared, we're going to be substituting y minus 2. And for x plus 1 over x, we're going to be substituting equation star, which is y. Let's do that. Alright, so originally we have x squared plus 1 all over x squared. Well, I'm rewriting the equation so that we see what we're doing. Plus x plus 1 all over x plus 1 is equal to 0. So this is the equation we have. Now we're going to be substitute equation star and equation star star here. So for x squared plus 1 all over x squared, we're going to be putting this, which is y squared minus 2, plus And for x plus 1 over x, we're going to be putting y. That is it. And then plus 1 equal to 0. So we have a quadratic expression. But let's simplify this quadratic equation. We have y squared plus y, so plus y. And then minus 2 plus 1 is minus 1, equal to 0. Now let's find y using the quadratic formula. So for the quadratic formula, we have y to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Here, our a is 1, our b is 1, and our c is negative 1. Now let's substitute this here. So we're going to be having y to be equal to minus b is 1, plus or minus the square root of b squared, that's 1 squared, minus 4 times a is 1, times c is negative 1, all over 2a, that's 2 times 1, since a is 1. So simplifying further, we're going to have y to be equal to negative 1 plus or minus the square root of. Now this becomes 1. Negative 4 times 1 times negative 1 is plus 4. All over 2 times 1 is 2. And then lastly, this gives y to be equal to negative 1 plus or minus the square root of 5 all over 2. So we've got two values for y here, which we're going to be splitting. We've got y to be negative 1, go with a positive, plus the square root of 5 over 2. And we also got y to be negative 1. This time, go with a negative minus the square root of 5 all over 2. So we're going to be substituting these values in our equation star in order to solve for the values of x. Let's continue on the next slide. All right, now recall that our equation star is actually x plus 1 over x equal to y. Now we're going to be solving for when y is equal to negative 1 plus the square root of 5 all over 2. So let's substitute this here. So we have x plus 1 over x equal to y. We have negative 1 plus the square root of 5 all over 2. So now let's clear the fraction. Well, we're going to be clearing the fraction by multiplying through by the LCM. And the LCM here is 2x. So use 2x to multiply through. We have 2x multiplied by x plus 2x multiplied by 1 all over x equal to, we have 2x multiplied by negative 1 plus the square root of 5 all over 2. Now notice we have 2x times x is 2x squared. Now this x can cancel off this x. So 2 times 1 is 2 equal to, and notice this 2 can cancel off this 2 so that we have negative 1 plus the square root of 5 times x. Now we have a quadratic expression. Well, we're going to be moving this to the left hand side. And when we do that, we have 2x squared. As this expression moves to the left, it becomes minus of the expression, which is negative 1 plus the square root of 5x. And then plus 2 equal to 0. Now, let's use this minus to open up the bracket. So we have 2x squared. You know, when this minus goes into this bracket, minus times minus is plus. I'm still going to be opening a bracket because of a common x. Now, minus times plus is minus. So I have 1 here, but this now turns to minus square root of 5. And then x plus 2 equal to 0. Now we're going to be using the quadratic formula to solve this quadratic equation. And if you notice, a is 2, b is this expression, which is 1 minus the square root of 5, and then c is also 2. Now, using our quadratic formula, we have x to be equal to minus b. What is b? B is this expression here. So 1 minus the square root of 5, that is minus b, plus or minus the square root of b squared. This is b, so I'm going to be writing 1 minus the square root of 5 squared, which means b squared, minus 4ac. 4 times a is 2, times c is also 2, all over 2a, that's 2 times a is 2. Now simplifying further, we have x to be equal to, I'm going to be using this negative to open up the bracket, so that we have negative 1, minus times minus is plus, square root of 5, plus or minus the square root of. Now let's open up what we have here. 1 squared is 1, and then 2 times 1 times negative root 5 is negative 2 root 5. Good. And then negative root 5 squared will give you plus 5. Good. Minus. Now 4 times 2, that's 8, times 2, that's 16. All over 2 times 2 is 4. Now let's continue this simplification on the next slide. So now let's simplify what we have inside of the square root. So we have x to be equal to negative 1 plus the square root of 5 plus or minus the square root of. Now we have 1 plus 5, that's 6, minus 16 is negative 10. Then minus 2 root 5, so minus 2 root 5 all over 4. Now notice that negative 2 is actually common. So let's factor out negative 2 from here. So we have x to be equal to negative 1 plus the square root of 5 plus or minus the square root of negative 2 out. Now negative 10 divided by negative 2, I'm going to be having 5. Then negative 2 root 5 divided by negative 2, I'll be having plus the square root of 5 all over 4. And notice that I have a negative inside of the square root, which means this is a complex solution. So the value for x will be negative 1 plus the square root of 5 plus or minus the square root of, I'm going to be writing the numbers, which is 2 times 5 root 5 all over 4 times I. Well, we have this iota here because of the negative inside of the square root. Well, there are two solutions for x here. In addition to the one solution we had before, x equal to 1. So making it 3 solutions for x. Now, recall that we also have the value for y to be equal to negative 1, negative root 5 all over 2. Well, I'd like you to solve this. Solve for the value of x using the same approach that I've used. Well, feel free to share your ideas in the comment section below. And if you enjoyed this video and have learned something from this video, go ahead and give this video a thumbs up. Subscribe if you haven't. Turn on the notification bell so you don't miss my upcoming videos. And like I always say, until next time, take care.